All right, good morning, grade 11s. Okay, so far you've looked at adding and subtracting radicals, multiplying and dividing radicals, changing from mixed radicals to entire radicals. And today what we're going to do is we're going to use the radicals and we're going to actually solve equations with the radicals. So I'm going to just start by showing you a quick example on page 211, and then I'll go through the 3 or 4 examples, working examples in your book with you. Okay, so the first thing that I have to do is very similar to when you learned about algebra. You have to isolate to get something solved. So for example, if I had x plus 2 is equal to 8, the first thing that I would tell you to do is we need to isolate the x. So to do that, I would subtract 2 from both sides. X is equal to 6. So I would have it isolated in order to solve it. Well, again, if you can see this here, that my 4x, my x is in the rooted value. I need to isolate the rooted value. So there's the first thing I have to do. All right. So first thing I'm going to do is add 7. 4x is equal to 20. Okay. So now that I have it isolated, I can get rid of my square root value. So how do I get rid of any square root value? I do the inverse, opposite, whatever you want to call it, and I'm going to square both sides. So that gives me 4x equals 400. Okay, and now I have to isolate the x. Last thing that I do, divide by 4, x is equal to 100. Now, the one tedious thing about doing rooted or radical expressions and solving for them is you should check those values all the time. First of all, I didn't talk about this. Again, we have to talk about restrictions. So when we're doing solving of equations, we have to have restrictions. And the only restriction that we got to be aware of is your variables cannot be negative numbers if they are inside rooted values. So for example, x here cannot be a negative number. All right. So I would go back in and I should check this. So my left side, right side, well, the right side is 13. That'll stay down here. The left side would be 4 times 100. Subtract 7. I'm sorry, that's pretty small. So 4 times 100, 400. 20 subtract 7 equals 13. I know I have it right. All right. Sometimes you'll solve these and you'll end up with a negative value. Can't happen because your value can't be a negative. All right. So these questions are not overly difficult, but they are a lot of work. So I'm going to go through a couple more examples with you, and we'll see how much work can be created. So not only are we going to do radicals, we're going to do a lot of factoring again as we go through. So let's look at page 212 now. So you can write it in your workbook if you want, or you can just follow and watch what I'm doing up here. So I've got y minus 1 plus 7 equals 13. All right. So the first thing that I have to do in all of these questions is isolate that rooted value. So I want to get the rooted value by itself. So I'm going to subtract 7 to both sides. So I get square root y subtract 1 is equal to 6. Okay. So not a lot of work so far. Square both sides. And I end up with y minus 1 equals 36. Y is equal to 37. There's my solution. Okay, so that one's not so bad. All right, fairly straightforward. Put 37 in here. 37 subtract 1 is 36. Square root of 36 is 6. 6 add 7 is 13. All right. Okay, so that one pretty straightforward. Morning, girls. All right, m equals square root 2 subtract m. Okay, like I said, these aren't difficult, but they create some work. So I have my square rooted value isolated. So now I'm going to get rid of it by squaring both sides. So I get m squared is equal to 2 minus m. Now, we just finished a unit on quadratics. So how do we solve any quadratics? We got to get it equal to 0. So I'm going to get it equal to 0. M squared plus m minus 2 is equal to 0. And then I need to solve this. So factoring it, okay? For the most part, I'd say 96 or 97% of the time, these are going to be factorable questions. Now, if they aren't factorable, you can either use the completing the square method, which I wouldn't use in this, but you can. You can use your quadratic formula, or you can graph them. So this would be a section where you might want to graph to find your zeros. All right. So now when I do this, let's have a look here. So I go square root, or sorry, the factors of m squared are m and m. And then the factors of -2 that add to give me that. So that's plus 2, -1. Okay. So plus 2 times -1 is -2. 2 and -1 make 1. So now what are my two values? My m value is -2 and 1. Okay. So here's why I check my solution. So I started with this. I started with m equals 2 minus m. So I put a -2 in there. Here, and then I have 2 subtract -2. Okay? So first thing I notice is I have a square root. It can't equal a negative number. So this isn't, even though this looks like it works, it can't work because when I do this, that's not happening. So what I do, and we need to get used to doing this because we do it a lot in grade 12, is we have to cross out what we call our extraneous roots. So an extraneous root is a value that we've solved for, which makes sense, but when I put it back in, doesn't work in this situation. So now I would do this again. I would put 1 in for my m value, so that's square root 2 subtract 1. 1 equals 1. That guy works. There's the only solution I can have for this. So there's where sometimes there's work created after we've done all my solving and everything, but I have to make sure that the values are equal in this case. Okay, so if you look in your workbook, it says 213. It says solve for the equation. So we've done that. Solve for my equation. And then it says check the solution for an extraneous root. Well, that's what this is right here. This is what we call an extraneous root. So it's a value that we solve for, but when put back into the original equation, it can't work. Now it says state the restrictions on the variable so that the equation involves real numbers. Okay, so restriction. I'm going to focus, just let me change this out for a second. The restriction is simply this. 2 minus m has to be greater than or equal to 0. This value in my rooted area, okay? It's not easy to see. Let me do it. I'll make it bigger. Okay, so if I'm looking at this square root 2 subtract m, I know that my value has to be greater than 0 in that. So I'm going to go over to here. I go 2 minus m is greater than 0. I'm going to add m to this side. In order for this to work, my m value has to be less than or equal to 2. Okay? But it may not work all the time, but that is my restriction on my m. So I actually should add that into my, oops, went the wrong direction here. I should add that into my equation. I should say m has to be less than or equal to 2 in order for this to work. All right? They don't necessarily have to be negative. Let me find an example for you in which, because like I said here, m can be less than or equal to 2. So realistically, if this was a -3, that could happen. But because I have m right here, this m value on the outside, that value can't be a negative because it equals my rooted value. There are possibilities in which the variable that you solve for is a negative and it works. It would work. Now look at this, look inside this bracket here. So to subtract a negative value here is going to give you a positive value all the time. So it can work. So it's not necessarily that the solved value is a negative number. All right. Okay, let's flip over. Let's go to, all right. Okay, here's the Mac Daddy of these guys. This is where life gets real and there's a lot of work to solve for a question. So let's look at page 214. All right, and they don't start easy on this one. This one's going to show you how much work there's involved in this. Okay, so I've got this. Square root 2x plus 5 equals 2 root x plus 1. Okay, now it gets real. So when I have two rooted values, I have to isolate one rooted value and I've got to square it. Now that in itself is simple enough. However, it's not as easy as it seems. So what happens here is this. I have to square this. So basically, I take that and I square it and I put brackets around it. So when I'm squaring, I have to square everything. So that's fine right here. This becomes 2x plus 5. That's okay. It's what happens on the right side that creates the work. This then is 2 root 2x plus 1 times 2 root 2x plus 1. I can't just get rid of this by squaring just this term and this term. You have to square it all. It now is a polynomial expression. So I've got to now multiply it out. This is where I said a lot of work comes into solving these simple questions. Okay, so I have 2x plus 5 equals. I'm going to FOIL this. So I got 2 times root 2x. So that's 2 times 2 is 4. Root 2x times root 2x is 2x. Then I have 2 root 2x plus 2 root 2x plus 1. Okay? My outside is that. My inside is multiplying those together. Now I have to simplify all of this first. That's 8x. This is 4 root 2x plus 1. I have 2 root 2x's and 2 root 2x's, so I add them together to give me that. Okay? So at this point, we're okay. We've done a little bit of work. Now I have to, again, solve this by isolating my rooted value. So my rooted value is that guy right there. I have to get it by itself. Okay? So to do that, I'm going to subtract 8x and subtract 1 to this side. So that gives me minus 6x plus 4 equals 4 like that. Okay? So I have subtracted 8x to that side, so 2x subtract 8x, and 5 subtract 1 gives me that. Now I have isolated my square root. I have to square both sides one more time. And again, that's that all squared. Okay, so I'm just going to take a second. I'm going to write this back up here. So I've got minus 6x plus 4 times minus 6x plus 4 equals 16 times 2x. Okay. All right, so I know it's hard to see, so let me show you this way. Okay, so this becomes minus 6x plus 4 times minus 6x plus 4. This, when I square all of it, 4 squared is 16. Root 2x squared is just 2x. So up here, I've got minus 6x plus 4 times minus 6x plus 4, 16 times 2x. So now I FOIL again. Like I said, there's a lot of work to this. 36x squared. Minus 24x minus 24x, add 16 equals 32x. So that's what I have right there. Okay. Simplify. 36x squared minus 48x plus 16 equals 32x. Subtract 32x to that side. 36x squared minus 80x plus 16 equals 0. I think that's correct so far. All right. Now, just let me think for a second here. Okay. Now I need to factor this. All right. So I've already done all of that and done all of this, and then I'm back to our favorite thing to do, and that's factoring. Now you could technically do this by graphing, but I'm going to factor this. Now I'm going to hope that this works. I've got to make sure I got this right, because I think it does. So if I go 2 times 6 times 4, no, that's not going to work. I was thinking this is a perfect squared trinomial. Okay, so greatest common factor. First thing I'm going to do is I'm going to take out a 4 out of all of these. That's going to leave me with 9x squared minus 20x, add 4, equals 0. So I've divided everything by 4. Actually solving, I can get rid of that. All right. So now I've got 9 times my product is 36. My sum is minus 20. So it looks like my factors would be minus 18 and minus 2. Okay. Again, know your times table. So now I'm going to go 9x squared minus 18x minus 2x plus 4 equals 0. Place my brackets. Factor out a 9x. Factor out a negative 2. All right, greatest common factor. I have that. Good. 2+ pages already. My answer, x equals 2 and 2/9. Okay. Okay, so my question, which was way back here, my question was up here. I would have to check and see if those were solutions. So rather than plugging them into here, I would, sorry, just gonna do this. Rather than plugging my solutions in, I would graph them. I would graph my original equation and see what I get as my intersection points. Okay, so they plug them in. So if you're looking on page 215, they plug in 2/9 this root in this case. Okay, so a lot of work in that guy right there. So I'm going to take a look at one more of these, one that's a little more difficult. So let's look at page 218. And I'm going to go through 5D on 218. And we'll walk through it as slowly as we can here. Okay, so I have square root c plus 7 plus square root 2c subtract 3 equals 4. So the first thing I need to do is I need to isolate one of those two. So what I'm going to do then is I'm going to take So the first thing I'm going to do right now is I'm going to subtract square root c plus 7 to the other side. Okay? Now, square both sides. That gets rid of one of my roots. And then I have to now multiply this out. Okay, 2c subtract 3 equals. All right, FOIL again, 4 times 4, 16. I'm going to shortcut just to save some time. 4 times this is negative 4 root c plus 7. This is also negative 4 root c plus 7. That gives me this, negative 8. That, and then that's plus. I like to put this in brackets as well, just so that I know it's there. So c plus 7, root c plus 7 times root c plus 7 is c plus 7. So you see that? Just going to erase that because there's no negatives. So that's what I have. All right. So then the next order of business, again, is to isolate that square root. So I'm going to subtract 16, subtract c, subtract 7, all to the other side. So subtract c gives me c here. I'm going to subtract 16 from this. That's going to give me negative 19. And then subtract 7, that's going to give me negative 26. Okay? 7 and 16 is 23. Subtract 23, that's negative 26. And that's equal to negative 8 c plus 7. All right? Again, the lousy thing about this, the numbers. The numbers is not great here. So what I'm going to do is I'm going to square and square both sides. Okay? So I'm going to cheat here, maybe, the calculator. Should know it. C squared minus 52c plus 676 is equal to 64 times c plus 7. C squared minus 52c plus 676 is equal to 64C plus 448. Okay, so I've been able to get rid of my square roots. Now it comes back down to factoring again. Get everything to one side and factor. So this gives me C squared minus 116C, and then plus, so 676 subtract 676 minus 448, 228 equals 0. And I think we can factor that. C and C, 228, half of 228 is 114. So I end up with C equals 114 and 2. Okay, now I could put those into my original equations to find out which one of them works. So let me okay, so the original equation was root C plus 7. C subtract 3, and that should equal 4. Okay, so if I put 114 in here, that gives me 121 plus square root 225. That should equal 4. Well, just looking at it right now, there's no possible way that this plus this could equal 4. That's 11. That is 15. That does not equal 4. So that guy doesn't work. So let's try this again. This time I'm going to put in 2. So that's 9 plus 2 times 2 is 4. 4 subtract 3 is 1 equals 4. 3 plus 1 equals 4. 2 works. So again, feel free to graph it if you want to check rather than doing the extra bit of work. That is a lengthy question. It's not a difficult question, but there's a lot of work and a lot of places in which we can make errors on this. All right. So what you're going to see if you're following along today is grade 11s, you're now done to the end of the end of chapter 5. So what I suggest then is for Thursday, complete to the end of 5.3. On Friday, work on the review, and I will post an assignment on Edmodo. I'll post an Edmodo assignment on Friday. That way you have a little bit more to do. That would clean up all of chapter 5. So when we got back in 2 weeks' time, so we have next week, we won't do anything. The week after, we'll do chapter 6. So that would conclude 5 and 6, and then we could move on to 7 at that point when we got back together, if provided we're coming back together. Okay. Morning, Railson. Okay, so I basically got another 15 minutes with you. It's good that you guys are on the comments. So if you have any questions or anything you want to look at through those, I'm just looking to make sure I don't have any. Okay. All right, so any questions from 5-2? I hardly had anybody on yesterday, so I would like it a lot better. Like tomorrow, let me know that you're on here in the morning. I'll be on all morning to answer questions. I suspect you'll have more questions on 5-3 than you did 5-2 and 5-1. I think 5-1 and 5-2 were probably a little bit easier. 5-3 is going to be a lot more difficult. So I'm hoping tomorrow that if I'm on here, I'll see some of you. I only had about 2 questions yesterday, I think, total. So anyways, anybody on here right now want to look at any questions? You can either comment, text, email. You've got about 15 minutes, and then I'm going to go on to the grade 12s for a half an hour, teach them their lesson, and then I'll be back on about 11:15 to answer any questions this morning. Okay, go through those questions then. If you're good with 5-2, then go through what I just showed you this morning on page 216 and 217. Go through those right now, and if you have any questions in the next 10 or so minutes, let me know. Otherwise, if you're working on it this morning, I'll be back on, like I said, between 11 and 11:15 if you need more help. I can mark the assignment. It'll be back to, so the question is, will the assignment be for marks? It can be for marks. I think what I'll do is you'll end up having 2 assignments. But again, if they're not going to help your mark, I'll exempt. But I'm going to mark them anyways. Okay, so I hope that answers your question. Yes, it'll be for marks if you want it to be for marks. When you graph an equation from 5-3, how do you know which roots will or won't work without substituting them in the original equation? Well, when you graph it, you'll get rooted answers. So the question is, let me have a look at, let's look at page 217. And we'll do 3D on 217. So I'm going to go through, I'll solve it with you, and then I'll graph it with you so you know how to figure out whether your roots work or they don't work. Okay? So I've got p equals square root 2 minus p. So this is exactly the same question. Exact same question we've already done. So in the example, except I think we used m's instead. So let's solve it. So we square both sides. So I've got p squared is equal to 2 subtract p. I get it equal to 0. I factor it. And now it comes down to, I need to check my answers. Okay? So I can substitute them in. I can solve that way. Or I can graph it. Now I'm going to try and graph this. It may not show up all that well because it's pretty light. But here's what I also suggest you do. To graph this, I'm just going to go back here for a second. So right now I started with this as my equation. Okay, there's my starting equation. Now, if I were to graph this, what I suggest is put the whole equation and equal it to 0. Okay, so I would have this, not y yet, p minus 2 subtract p equals 0. So that's what I would have as my equation. Now what I want to do is graph it as y equals p subtract square root 2 minus p. Like that. Okay? So that's what I want to graph it as. So I'm going to go to my calculator here. Y equals. And again, you're going to have to do the same thing. I have to switch this to x. Subtract. Okay, so now this is the graph that I got. Now it's going to be very, I don't know if you can see that, but this is the graph I had got right here. It crosses the axis at one spot, which means that it only has one rooted value. Okay, so that's how I can tell. So when I go back to my solution right here, I saw my solution was -2 and 1. Okay. That did not turn up on here. This is the only mark that I have, which is right here. Okay, so this graph, I'll draw it on here. Looks like that. And this is the only place that it crosses. Now remember, when I get the equation equal to 0, okay, then when it's equal to 0, all right, then it's where it crosses that axis. So that's how you can tell whether or not it's an answer or not. Okay? I hope that helped. Okay, I've got time for one more here. Page 204. Okay, so let's go to page 204 and 4D on page 204. 4D. Okay. All right, so I have okay, so I got to FOIL this. Okay, so 8 times that is 8. Cube root 4y squared times 2y is going to give me cube root 8y cubed. Okay, so that's this times this. Going to multiply that by that, so that's going to give me plus 40y cube root 4y squared. This times this is minus y cube root 2y. And then that times that is minus 5y squared. Okay, so looking at this right now, I've still got a little bit of simplification to do. I need to break this down. The cube root of 8y cubed is 2y. So I've got 8 times 2y here, plus. I can't do anything with this guy. This stays as 40y cube root 4y squared. Okay. This, of course, can't break down either. 2y. And I've already broken this down to 5y squared. So then basically, the only thing I had left to do that I could simplify is this right here, which becomes, there's my final answer for that question. There's not much simplifying that I can do. All right? There's no perfect cube. 4 is not a perfect cube. Y squared can't be cubed. 2y can't be cubed. That's it. I can't add them. There's nothing alike there. That's all I have. All right. Okay. I'm going to sign off on here right now. Like I said, I will be back on in about a half an hour, probably a half hour to 45 minutes. I've got, looks like 2 lessons to do. So probably 45 minutes I'll be back on here. I like that all of you, there's a lot of you on here today. So that's great. And like I said, be on here tomorrow. Yesterday was a long morning because I only had 2 questions the entire morning. So be on tomorrow. But also, if you need help today, come back on at 11:15, and I will. I'll go through any of the questions that you have. I'll go through with you later this morning. Okay. So thank you for being on here. I see I've had 7, 8, 9 of you on today all morning, so that's most of the class. All right, let me know if you need anything. We'll be on a little bit later.